Okay, so sensors and sensor fusion are one of the trends that are driving us down the road to autonomous vehicles. But it's just as important to talk about how those vehicles are being powered. Car companies are providing more hybrid electric or fully electric options to meet customers' demand for more fuel-efficient vehicles, as well as government regulations for lower and lower emissions. As an example, the Chinese government is deploying 100,000 charging stations to meet their goal of 5 million electric vehicles on the road by the year 2020. And the German government's going a step further by mandating that 100% of vehicles are zero emissions by the year 2030. That's only 13 years away. And this introduces a major challenge because the control systems for electric vehicles are more complicated than those for traditional vehicles. Now, just a few years ago, we had Subaru on stage, and they talked about how moving from the road to the lab reduced their test time by 95%, and it increased their test coverage. Now, we want to bring that type of impact to more and more vehicle providers, so we've been working with our HIL specialty partner, OPAL-RT. To learn more about it, I want to bring out two people who live their lives a quarter mile at a time, Yannick Martin and Nadine Herreri. Yannick,
how are you?
Great, welcome to NI Week.
Thank you, thank you.
So can you tell us a little bit about OPAL-RT and the work you do?
Sure. OPAL-RT designed digital simulator and hardware-in-the-loop test system for electrical, electromechanical, and power electronic test systems. So the mission of our team is really to design cutting-edge, real-time simulation technology for engineers and researchers around the world.
Now, you guys are the real experts in this power electronics space. Can you explain what makes these systems more complicated than traditional systems?
Yeah, sure. The main difference between typical test system and the one designed for power electronic is that the simulation rate needs to be much more faster. And this is where OPAL-RT comes in. Due to the speed of the input and output of the control system, the simulation needs to run in the order of 1 megahertz, which is about 500 times faster than typical simulation rate.
Wow, so 1 megahertz control loop rates, you're not going to reliably get that from a processor-based system, so that's where running these models on FPGAs come in, and you've been working hard to make that easier for customers to do.
Yeah, OPAL-RT spent many years developing an electrical solver on FPGA called the EHS. Take models from industry standard modeling environment and deploys them directly to FPGA with no compilation time. Nadine, could you show us?
Absolutely. So here's a typical power conversion system in multisim. I can export the circuit directly from multisim. And then I can dynamically load this new model onto the EHS solver core that is already loaded and running on the FPGA target. Immediately, my simulation is running at 4.7 megahertz in a Flex Rio, and all of that was done without having to wait for an FPGA to compile. That means that you can test and iterate on your designs much faster.
So we've been,
Yeah, we can clap for that.
All right. So we've been hard at work, and we are very pleased to announce that the EHS solver is now available on all Zynq and Kintex 7 FPGA platform from National Instruments.
That's phenomenal. So all of our current FPGA targets can now use this technology. Now, that's not the only challenge with testing these power electronic systems. You also want to test the power levels of these systems, and they can be quite high.
Yeah, well, customer wants to test the inverters as a single unit, syncing and then sourcing a lot of power. And combining this to HIL simulation makes the realism and the physical test close to the physical testing and the test coverage and repeatability of HIL simulation. So, I'm very pleased to announce that we're going to add this capability to the NI platform this year by releasing a new SLSC board that will simulate inductive loads in the 1 to 5 kilowatt range to make those type of testing a lot easier.
Wow, up to 5 kilowatts of power for these systems. So that's two major announcements to address the two major challenges of power electronics HIL tests. I knew we were working with the right company.
Thank you, Jamie.
Thank you, Yannick.
See you.
Thank you, Nadine.
Have a great day, Jamie.